What if the DNA in your cells break? DNA breaks happens all the time, and normally the cells can cope with this on their own. But in tumor cells, there's often mistakes in these repair mechanisms. I study when there's a break in the DNA of a cell and how this is being repaired. Now, how can you study this? There's two things to do: make the break and observe the break. For making the break, we use the now very popular CRISPR-Cas9 system, which is basically a molecule that can be directed to a specific location in the DNA and make a break. And then the cell starts repairing this DNA, but during this process it often leaves a scar. And this scar is basically the thing that we want to measure. We needed a fast and cheap way to see if these scars were introduced into the DNA. We developed a web tool called Tide, and this tool can measure in a quick way how well the CRISPR experiment worked. In the first year when it was online, we had more than 10,000 users and was used in more than 100 countries all over the world, which was a bit surreal. And then, went to conferences and people started to recognize you just for this tool, which was quite fun to experience. I think the key to the success of this tool is that since a lot of people were using the CRISPR tool, now all of a sudden within a week you could see if your experiment was working or not. Now we had the tools in hand, so we went back to solve the biological question, how DNA is repaired within the cell nucleus. And we found that different repair mechanisms are working, and they also go with different speeds in repairing this break. During my PhD, I did spend nights in the lab. This was because I was studying the speed of the DNA repair, and apparently this is rather slow, so this kept me quite a long time in the lab. What I found challenging in this work is that it's sometimes hard because you cannot see what you're studying. This is also the interesting part because now you can come up with creative ways to detect what you want to know.